Hello everyone, hope you guys are doing well. In this video we're going to continue with the Biochemistry 2. We're going to talk about lipids. So we got contents as the other topic, and we got our learning objectives. You please check them out. And then what are lipids? So lipids, they mostly contain carbon, hydrogen and oxygen, and sometimes phosphor element. We know lipids from our life, they are oil in terms of oil and fats. For example, as you see in the picture, we have the butter, and at room temperature, when they are solid, we call them fats. And the butter is the fat, which is essentially the lipid. So lipid divide into two types. Some of them are solid, and then some of them are liquid. The solid one we call fat, the liquid one we call oil. So an example for those could be butter for the solid, and then for the oil you can see, for example, this looks like a sunflower oil. Sunflower oil. Okay, so what are lipids? Lipids are largely nonpolar, meaning that because they have carbon and hydrogen bond, and this bond is nonpolar compared to, for example, oxygen and hydrogen, where we have oxygen is largely electronegative while hydrogen is positive. We have polarity in here while we don't have any polarity, and we know that the lipids have a lot more carbon and hydrogen than oxygen. This is why lipids are non-polar. And you know that water is polar. That's why non-polar lipids won't dissolve in non-polar lipids won't dissolve in water. Okay, which is why they are hydrophobic. And lipids are mainly defined by their properties, meaning that we will actually go by each type of a lipid, and we will discuss their properties. And also they have the property of storing energy. They are used in chemical messaging, like cell messengers, like in our body. They do transport. They are also good for thermal body insulation. For example, we have the body fat in our body, which is good to protect us from cold. If you tend to have more body fat percentage in your body, you tend to have a better insulation, and you get less cold. Okay? So, types of lipids. There are four types. One, which is the triglyceride. Second is the phospholipids. The third is the steroids, and the fourth one is the waxes. Phospholipids is the one that has phosphor in it. We're going to discuss with you triglyceride and steroids. We won't be touching phospholipids and waxes this time. So, lipid molecule looks like this. As you see, this is a triglyceride. We will talk about how do we get it. So this part of the triglyceride is coming from fatty acid, and this part is coming from glycerol. So, quickly about the fatty acid. Fatty acid is a common name for a long-chain unbranched carboxylic acid, meaning that if you remember, we talked about carboxylic acid with a functional group like this, right? In proteins, we did a bit of review. And if this chain has lots of carbon chain, let's say I've got like 8 carbons, and I have ending with methyl like this, the longer it gets, we no longer call them carboxylic acids, although they are the group of carboxylic acids. We call them fatty acids, because they are actually involved in making lipids. which is why we call them the longer chains, the fatty acid. Even if you check in here, we started with the 4 carbons in here, and then you see we got 8 carbons, and then we got 12 carbons, we got 14 here, 16. So the longer it gets, and we have the names for them. We have common names, and we have IUPAC names. We know that 4 carbons is root is butan. That's why we call it butanoic acid. And the common name is butyric acid. And we know that we can find it inside the butter. Okay, so what about the free acids? So free fatty acids are the type of carboxylic acids that they are not part of lipids themselves, okay? That's why we call them free. But the fatty acids are the ones that are making triglyceride, which we will show in the next pages. So for example, I've got 3 fatty acids in here because they are making triglyceride, meaning AKA, as known as lipids, a part of lipids we talked about in here. This is why they are not called, they are non-free. They are not free, okay? But the free acids are the ones that do not make triglyceride, but they are just existing on their own, okay? They are existing as carboxylic acid. For example, if you look this omega-3 acid, the fatty acid, this fatty acid is actually free in its form. He doesn't make no triglyceride, okay? Free acid, free fatty acid, no triglyceride, okay? Okay, so now let's continue with the fatty acids. Fatty acids are coming into forms saturated one and unsaturated one. If you remember saturated, we talked about, we know that they all have single bonds between carbon and carbon, while the unsaturated one either have a double bond between carbons or triple bond. And when you have all single bonds, like look in here, the way it will look, so these are all the gray area, gray stuff is the carbon in the middle. And the white ones in here, they're hydrogen, this is oxygen, and this again hydrogen. So it ends like this. So carbon, carbon, I'm just doing you butyric acid. Okay, and then we got COOH, right? So as you see, it looks like a straight shape. You see, this looks like a straight shape. That's why when they are together, we have another fatty acid, and then we have another fatty acid. They can closely pack, close packing, which makes them have higher density, and that higher density gives higher melting point. Understood? So melting point, higher melting point. While when you look at the unsaturated one, for example, if I will do one unsaturated bond, you would see that the way it looks. So there is a little bit of a bend. You see that there is a bend in here. We have certain degree angle, okay, around, I don't know, 60 degrees. There is a bend of a 60 degrees in here, which as you see, it's obvious over here. And when they are put together, they can't do close packing. No close packing. And which is why they have lower density, okay? Lower density, and then lower melting point. Understood? Melting point. And that's why when you have saturated fatty acid, most of the time, saturated fatty acid, they result in having like a solid lipids such as butter. it's not fully made of saturated, but it has more content of saturated rather than unsaturated, because the unsaturated oils will have a lower boiling point. You see, they are more bent structure. These are all unsaturated. And unsaturated will have a lower melting point, meaning they will be in oil state, and then the saturated one will be in a fat state, meaning solid in here, and this is liquid. Okay, and then now essential fatty acids, we need to go over them quickly too. So the plants, seeds, vegetable oils, they are good sources of omega-3 fatty acids. Fish, shellfish are good for omega-6. So you need to know this by heart. And the way we do check this is that we always look at this end. Okay, we know that this is a fatty acid, and we start counting from here. 1, 2, 3. The first double bond we encounter is going to give us omega number, which is omega-3 on a third carbon we have. We don't care about this one. We only care about first double bond, okay? So now, on here, I've got 1, 2, 3, 4, 5, 6. So this is omega-6 fatty acid. And then I look 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is why this is going to be omega-9 fatty acid. Okay, so let's quickly wrap up the triglycerides. So triglycerides are esters formed from fatty acid with polyfunctional alcohols. And then we're going to discuss what is the polyfunctional alcohol. The products of condensation reaction, meaning esterification, between 3 molecules of fatty acids and 1 molecule of glycerol, which is going to give us triglyceride. So propane is 3 carbons, right? 1, 2, 3 carbon. And it says triol, meaning OH here, and then OH here. And then you fill it with hydrogens, just enough to balance the 4 valency. Now you have your glycerol. The other name is propane. Propane, 1, 2, 3, triol. Okay. So this is the esterification reaction. We have done it in the class many times. So I've got glycerol, right? I wrote it here. And then I put here my fatty acids. Fatty acids, they are carboxylic acids. And when we go through esterification reaction, we remove the water from here. Esterification is also is also condensation. Condensation, if you remember, was going from gas to liquid. That is the process. And over here, because we create water in the end, we make the liquid, we call this process condensation. Okay? So what did I do? I just removed this area. You see, I removed this. And then I connected this chunk, okay, this chunk with this chunk, as you see here. And then look at my product. This is what I got as a product. So you see, I removed the water, I removed 3 waters, and this is over here. Now, when this, you see this R's are given to us, it could be, it's a variable, right? Variable. So this R's could be CH2, CH2, CH3, for example, for butyric acid. If all of the R's are the same, R1, R2, R3, we call them simple triglyceride. But when these R's are different, for example, like in here, you see, this is R1 and R1, but over here I've got R2. And when you have like this, the 2 amino acids, right? I mean 2 carboxylic acids and 1 different, you only have 2 choices for triglyceride. The first one is when you have both of the same on top and the other one in the bottom, or the different comes in the middle and then the other ones goes up and top. Okay, and we call them mixed triglycerides. Okay, so now about the physical properties of triglyceride. Again, saturated triglycerides are mostly solid at room temperature. I told you because of rod shaped structure gives you a chance for close packing, and close packing gives you higher density, and which gives you higher melting point. That is the reasoning. Now, unsaturated triglyceride, they are liquids, no close packing, and they have weak intermolecular forces. Okay? So, when we tell that they are solid, liquid, and they are fats, the fats is just another name to say that they are solid, and oil, we just want to tell them they are a liquid. Now let's look at the list that I have. I have updated your PPT, and when you look at here, this is the fats and oils that we encounter in our daily life. So I've got the butter, right? We know that the butter is solid, meaning that it is a fat, right? Fat. And as you see, the saturated fatty acid percentage in here, I've got lauric, myristic, palmitic, stearic. I got different kinds of fatty acids in there. But as you see, the percentage wise, if you add them up, I will have more of saturated and less of unsaturated fatty acids. So unsaturated fatty acids are taking about 30 plus, like 48%, but I have about 52%, so 38 plus 14, 52% of saturated fatty acid, which is why it is in a solid state. And if you check out the other ones, you would see that the more saturated fatty acid we have, the solid state it's going to become. Okay? And even if you look at the coconut oil, we call it a coconut oil, but when you see, look at the coconut oil, the percentage we have for saturated fats. It's like 63 plus 13, which is 77, and we got 63 plus 13, 76, and this is 24 in here. So we know that normally coconut oil is solid at room temperature, and this is why, because we have more of a saturated fat in it and less of unsaturated fat. Okay, now we're in the chemical properties of triglycerides. We're going to talk about the hydrolysis. In the previous reaction, we actually made the triglyceride. We removed the water with the condensation reaction, right? But in this case, we're going to go backwards. It's just the same reaction. So the condensation is the way to go this direction. This is condensation. And then backwards is going to be hydrolysis. For hydrolysis, you need following conditions. You need to create acidic environment, and you need to give it a heat and provide the water. So this will just break down from triglyceride, and it will give you back glycerol and your fatty acids. Okay, and then the other one is going to be going the hydrolysis with the bases. And this process is called actually saponification. And then saponification, you need to provide sodium hydroxide and the heat. So this was acidic environment, acidic hydrolysis, and this is an alkaline, or they sometimes call it a basic hydrolysis. So in basic hydrolysis, I have done this with you guys, so I'm going to show you. Normally bases, when you throw them into the water, they ionize into sodium plus OH negative. This is your grade 10 knowledge. And this OH negative comes from this side, and then sodium comes from this side. So OH hit the carbon, and then another OH hit the carbon, because I have 3 of them. So OH hit the carbon, and then sodium so this bond is going to break from here, and then when it's broken, it will carry negative charge, the oxygen, because it has one bond left. And then positive and then sodium will attract each other, and this is what they will make. So sodium will attach to the fatty acid. So fatty acid was looking like this, negative, and then sodium comes here, and we can write it like this. We can just attach them to each other. This is just like how did you get your fatty acid back? Instead of hydrogen in here, you're gonna just write sodium. Okay, this is just a hydrolysis. You get your glycerol back again. Glycerol back. Okay, and in here the saponification, the way it works, we grab the triglyceride. This is triglyceride, and then we grab a base, which is, let's say, sodium hydroxide, and then we get the soap. And look at this soap. So we had the triglyceride, right? We add sodium hydroxide, which is the base, and we call it a lye, and then oil is here, is the triglyceride. We get the product glycerol, and this final product with the sodium is going to be called soap. Okay, we got the 3 moles of this soap. So we got the 3 moles of this soap, and that's our product in the end. We can do this esterification, the basic hydrolysis, or we call the saponification reaction, using potassium hydroxide. So the sodium hydroxide was one of the options, and potassium hydroxide is the other option. And with the potassium hydroxide, you get again the same thing, but instead of hydrogen, you're gonna write here potassium. Okay, potassium will carry the +1 charge. Now you have your soap for the 3 moles of the same salt. The reason we call them salt, like instead of, if I have RCOOH, if I have instead of hydrogen any other metal, this compound is gonna be called salt. Okay, so these are salts, while this one is fatty acid. Okay, so what is the difference between them? We got sodium hydroxide and potassium hydroxide. Sodium hydroxide is the one that we get our solid soap. They create harder soaps, and they are less soluble. Like when you make this process, the saponification process, you will see like precipitate in the bottom. And that precipitate is gonna be your solid in the bottom because of the density. Okay, and the reason is they are less soluble. So when they're less soluble, they're gonna go to the bottom. But the one with the potassium hydroxide over here, you have the stuff is more soluble. So this is gonna be all over the place, like the soap in the environment. And that's where you get your liquid soap. So they are more soluble, and they give the liquid soap. So you need to know you get your liquid soap from the potassium hydroxide, and you get your hard soap from sodium hydroxide hydrolysis. Okay, so about lipids and health, this is the general information. You need to read all of this stuff. We can give you a small 0.5, 1 point question, but just give it a read. If you see something essential, you can memorize it, but these are pretty general knowledge. For example, fats should provide 30 to 40% of our daily energy intake. Carbohydrates give us around 50 to 60, and proteins are 10 to 15%. But this is, to be honest, there is many diets. This is just the average diet nowadays in the world. We don't know what's going to happen in the future, if this is going to change or not. But if you look into different kind of diets, such as paleo diet, if you would look, for example, carnivore diet, all the new diets I told you about, they have a different percentages. This is the one that average in the world right now. The reason is because in the world we didn't have as much food. Right now we have. and people wanted to get something cheaper, so economically whatever is the cheapest is the carbohydrates. Carbohydrates are easy to get. But now the new diets are emerged because we have more, let's say, money in the world, we have more food in the world, and people can eat whatever they like because they no longer need to be that much economic. So now we have different percentages. Okay, now regarding the steroids. Steroids are the class of lipids with a characteristic arrangement of 3 6-membered and 1 5-membered hydrocarbon rings. Where do we get the 6? You see 1, 2, 3, 4, 5, and 6 ring. And then I have another one. 1, 2, 3, 4, 5, 6. I have another one. 1, 2, 3, 4, 5, 6-membered. And the last one, 1, 2, 3, 4, 5 in here. So as soon as I see this backbone, I know that we are dealing with steroids. For example, cholesterol is actually all of the mother of all of the steroids, like where we get all of our steroids. Many steroids have one or more double carbon bonds at positions, you see, 4 and 5. So position 4 and 5 in here. And where do we have the 6 and position 6? So for example, cholesterol contains 2 methyl groups. In cholesterol we have 2 methyl groups, but it has the same backbone, you see. And then you have steroid hormones. We got the male hormones and the female hormones. Male hormones, as you see, they have the same backbone, the testosterone. And then we got androsterone, and then as you see, have the same backbone. And then female hormones, the same thing. We got progesterone, estradiol. And then this is the general knowledge that you need to know. And most steroids are hormones, the chemical and messenger that regulate metabolism and immune functions, sexual characteristic and reproductive functions, or the synthesis of muscle and bone tissues. Like all of the steroids, more or less, they are our hormone. They are taking they comprise our hormonal system. So as soon as you see this structure, you know that you're dealing with either steroids that are hormones or just in general steroids. So steroids, the other one we have is called anabolic steroids. They use this a lot in bodybuilding industry. They use it as a synthetic drugs that mimic, like give the effect of testosterone. So you see, because testosterone and, for example, Dianabol, which is very famous in the industry, they have the same backbone. When you give it to the body through the syringe, your body does not recognize whether this is a testosterone or not. It looks like a testosterone to it, so it right away like escalates protein synthesis, cellular growth. That's why you get a lot of muscle and bone tissue increases over there. This is another one of the steroids. We won't really ask you really hard questions in here. The main thing is that you need to be able to recognize what's the backbone of the steroids. Now regarding the cholesterol, we told you about cholesterol have the same backbone. We have 2 types of cholesterols. This is the general knowledge again. We got the high density one and the low density one. The high density one normally goes back to the liver. So the blood flow goes back to the liver. And while this stuff, the lower density ones, they get stuck in our arteries. As you see, we have it in the bottom. And that's why people with who have low density lipoprotein, which is the bad cholesterol, will have these plaques in their veins, in their arteries. That's why they will have heart problems. And this is the general knowledge you need to know. High density is the good cholesterol, and the LDL is the bad cholesterol. You need to have good cholesterol for a good hormonal balance, because we told you about that our hormones are coming from the cholesterol. So if we don't have a good cholesterol in our body, it's going to disrupt our hormonal balance. Okay. About the carbohydrates. Carbohydrates are our main energy source. I already told about this, about like 50 to 60% of our food is coming from the carbohydrates. So carbohydrates, you can find it like all of this food, the bread, and then like sugary stuff, and then you have all this grains, oats, and then bread, even carrots, and all the fruits and vegetables, they all have carbohydrates in them. So carbohydrates are the main energy source, and they are most abundant biomolecules on Earth. Like we have them very easily available, that's why they are kind of cheap. And one of the four categories of organic molecules, like proteins, lipids, and nucleic acids were the other ones. We already did proteins and lipids. Now we're talking about the carbohydrates. They serve as an important structural component. How? For example, in the photosynthesis, if you remember, we were creating glucose from carbon dioxide and water using the synthesis of the sun energy. And this process is photosynthesis, gives us the glucose. The glucose is actually carbohydrate. And this is the way it looks. Now we're gonna talk more about this. You guys need to know for sure the photosynthesis reaction for your exam. Photosynthesis, we already did cover that in the Biochemistry 1, and aerobic respiration. Okay, so now let's continue. So carbohydrates have this molar ratio, 1 carbon to 2 hydrogen and 1 oxygen. As you see, if I divide everything by 6, you would get 1 to 1 ratio. Now, if a carbohydrate has 4 carbons, we would have this formula, C4H8O4. Okay, so carbohydrates, they are also polymers, and their monomers are called monosaccharide. Monosaccharide, it is their monomer. Simple sugars and bond to form complex sugars. So simple sugars that are monosaccharides, like a monomer, they come together and they make complex sugars, which is the polymer. And the polymers are called polysaccharides, made of long chain of monosaccharides. You add all of these monomers together and you get your, like you add many monosaccharides and you get the polysaccharide. A simplest example of monosaccharide is glucose. Now, simple carbohydrates such as glucose is very easily digested and it gives us quick energy. Glucose is, for example, what it is. We have, let's say you get some sugary drink. And then right away when you drink that sugary drink, such as, let's say, Coca-Cola, there are lots of glucose in it. Right away when you drink it, you will feel energized because you get simple sugars that are very easily digested. It doesn't take time for them to get digested. Now, the monosaccharides that we will cover, the first one is the glucose we already talked about, and then we have fructose and ribose. Glucose have formula of C6H12O6, and fructose is also actually has the same formula, C6H12O6. Ribose, on the other hand, have 5 carbons, so it will be C5H10O5. Glucose and fructose, they are, if you remember, we talked about, they are isomers. They have the same molecular formula, but they have a different structure. Okay, and I will show you how in the next page. But before, I need to show you about, I need to talk to you about this glucose. So glucose, I have here, have 1, 2, 3, 4, 5, and 6 carbons, right? It exists in open chain form like this, open chain. And then it can transform into cyclic version. So this is closed chain. And they sometimes call this cyclic. and this one acyclic, meaning no cycle. Okay, and we're going to discuss with you how this cyclic thing happens, but before I go, I just want you to pay attention how the glucose looks. So the first carbon, as you see, the first carbon we have here aldehyde. The last carbon is primary alcohol. Now second, third, fourth, and fifth carbons, they are secondary alcohols. Okay, so now let's go back into glucose, and we got here, so the first, second, third, fourth, fifth, and sixth carbons are here. I told you the first one is aldehyde, the last one is primary alcohol, and the second and third and fourth and fifth, they are secondary alcohols. Okay, now let's look at the fructose. In fructose, the first carbon is primary alcohol, and the last carbon is primary alcohol. But the second one is gonna be ketone, carbonyl group. We already covered the ketones with you, okay? But it has the same formula. It's gonna be the same formula for both. Now, ribose, on the other hand, have 5 carbons, and then the last one, it's going to be primary alcohol. First one is going to be aldehyde, and then second, third, and fourth, it has a secondary alcohol. If you look at the glucose and ribose, the only thing, the difference is between them is that it doesn't have this one of the secondary alcohols in here. You see, we got 2, 3, 4, but in fifth we got in glucose secondary alcohol, but in the ribose it just finishes off with the primary alcohol. So it has 1 less carbon. So it will be 1 less carbon, 2 less hydrogen, and 1 oxygen less. Okay, and then deoxyribose in here, it's just like, you see this oxygen, we just don't have that oxygen in here, and this is deoxyribose. For this structure, the only thing you need to know how the glucose looks for sure. The other ones, if we need it, you're going to give in a table, but you need to know the glucose, and it would be better if you know the fructose too. Okay, now about transforming into the cyclic form. Now let's say I start with this glucose, the first carbon, second, first carbon, second, third, fourth, fifth, and sixth. The main thing you need to understand that on the fifth carbon I have OH. You see this one here? Oxygen attaches to this carbon, and then hydrogen attaches to this oxygen. And the way it looks, if I will write the semi-state of this guy, you see this carbon up top? So the carbon up top will be looking like this. Okay, the first carbon, and then second, third, fourth, fifth, and then the sixth one is here, right? CHOH. So the other ones are just staying the same. So HOH, the OH, and then I've got HOH, and then H, and then you see this oxygen now, it is connected to this carbon, right? Connected to this carbon. And we sent this hydrogen from here up to the oxygen in here. And that's how it looks. And if you start numbering 1, 2, 3, 4, 5, and 6, you would see that the first carbon again has, as you see, hydrogen and OH, right? So I've got hydrogen and OH. Now second carbon, I've got H and OH, so H and OH. Third carbon, I have H and OH. Fourth carbon, I have HOH, HOH. And then fifth carbon, I have H, as you see H. And then this guy is left outside, so I put it up here, and then the other bond goes to oxygen. You see, it's oxygen, now it's connected everything together. So the first carbon. So this is the cyclic forms, and when you write the line diagram of this, line diagram, so this is oxygen, and when I draw the line diagram, I'm just gonna draw OH, I don't write hydrogens, then OH, and then CH2OH, like this. Or I can even do the last one like this. You know that this part is carbon, right? The corner. So this is your glucose. Now, I can do the same thing with fructose. You see, like in fructose, on this side, you see the fifth carbon now went in this time to the second carbon, you see? And our cycle will be made from 1, 2, 3, 4, and 5 elements. You see? It goes like, starts with this carbon, and then this carbon, 3, 3rd, 4th, and 5th. Now you make the same way, and you would end up with this way of looking fructose. Now the ribose is shown in here too. It's just the same thing with glucose, but just one less of this, okay? And you would get exact same thing. So I would recommend you to practice this. This is going to help you out to write the structures. So I've got the glucose, fructose, ribose in here. These are the line diagrams, okay? Line diagrams. Once you have your structure, you can compare it with them, okay? You know that you can just turn these shapes around. If you have like your oxygen in here, let's say your oxygen looks like this, and here all you need to do is just turn this away and your oxygen will be top. And then you can compare it with the structures. Now writing it like in the bottom or in here, don't worry about it. We don't go that deep with you guys. It's not your problem at this point. Now, we told you that we have monosaccharide, right? Monomers. Monosaccharide. Now, those monosaccharide, they need to be in a cyclic form to add up together. So monosaccharide add another monosaccharide gives us disaccharide. Okay, disaccharide. Now that disaccharide way, it happens like this. So if you would recognize this is your glucose. We know that this is the last carbon, last 6, and this is 5, 4, 3, 2, 1. So first carbon connects with 1, 2, 3, 4, 5, and 6 carbons, so with the fourth carbon. When you bring them together, they both have OHs, right? Now this is again the condensation reaction. Condensation reaction, the water is coming out. You see this? But pay attention that it connects first carbon with the fourth carbon. Okay, this is very important. You need to know this information. And then we remove this water from here, and then we connect just this with oxygen. You see, like a bond like that. And then look at here. Now, first carbon connected with the fourth carbon, and it's this called glucosidic link. And when they connect together, they give this disaccharide has a special name. It has a special name. It's called maltose. Okay, it's not called. Sorry, it's not going to be called D-glucose. There is no such thing. Okay, it is going to be called maltose. Now, maltose, you see the first carbon and the fourth carbon. If you number it, you would see it. 4, 5, and 6. The same thing in here. This is 5, 6, 3, 2, and 1. 1 and 4 carbon, they connect with glucosidic link. So made up of 2 monosaccharides, they make disaccharides. Now glucose combine, in here we got glucose combining with another glucose, right? This is the one we practice, but there are other ones that we see in the nature. For example, we have inside the milk lactose. Okay, lactose is another carbohydrate, which is the combination of glucose and galactose, and they have combined like this glucosidic link again. And not in all of them, it's going to be 1, 2, 4, 1 and 4 carbons connected. The other ones might have 1 to 2 connection. For example, like in here. In this one, we have 1 to 2 connection between galactose and fructose. But you're not going to worry about this. This is not what you will cover. You're only responsible for 1 to 4, which is the glucose and glucose addition. Okay? Don't worry about glucose plus fructose, disaccharide. You don't have to write the structure. We might give you the structure and ask you the question, but we won't ask you to draw the structure. Okay? Now, about the disaccharide, we know that we got glucose C6H12O6, right? And I add another glucose C6H12O6. And I know that I remove the water, right? So remove the water, and I can get the molecular formula of maltose, which is going to be C6 plus C6 is going to be C12, and this is going to be H22, and O is going to be 11. That is the formula of maltose. Okay, maltose. Now, we can have a triose too. You see, if we can add another glucose to it, so glucose, 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 it gives you maltotriose. Now, the more complex the structure gets, the longer the chain gets, it becomes harder to digest it, okay? The polymers of carbohydrates that have less than 20 monomers are called oligosaccharides. So, meaning that if I have monosaccharide, add another monosaccharide, if it keeps adding like this, right? It keeps adding, and if it's less than 20, equal to 20, it's less than 20, not equal, it's going to be called oligosaccharides, okay? Oligosaccharides we have inside, for example, carrots. If you eat the carrot, it does not digest right away. It takes long time, right? That is why, because we need to break down these glucoses in our body. That's why it is taking longer time for us to digest them. And they have a longer lasting energy due to that. Okay? So, like, even if you see it, like when you cook the carrots for about more than an hour, you will be able to get the sugar out of it after an hour. You taste the water that boils the carrots, you could see that it gets sweet after an hour. Now, polysaccharides are the ones that have more than 20, okay? So they have more than 20 monomers. So less than 20, we said they are oligosaccharides. So less than 20 is gonna be oligosaccharides. More than 20, it will be polysaccharides. Now, they are known as glycans. You need to know this. There are homopolysaccharides and heteropolysaccharides. Homo ones, it means that you add the same monosaccharide, meaning glucose plus glucose plus glucose. You see, it's the same monomer. But when you add glucose on top of fructose, and then you mix up other stuff, it all becomes different monosaccharides, right? So that's why it will called heteropolysaccharide. Now, starch is made up of only glucose, meaning that it is homopolysaccharide. And then it's a storage form in plants. And it's the main carbohydrate in human diet. For example, bread, pasta, cereals, potato, and rice. So this stuff takes longer time for us to digest. That's why when you eat like pasta or cereals, potato, you feel sleepy. It does not digest right away. It needs time for digestion, and your body gives you a sign that, okay, you need to rest so I can digest this food. That's why you feel sleepy. But instead, for example, if you would have eaten an ice cream which has glucose available in it right away, you know that it's super easy to digest right away. When you eat the ice cream, you feel energized and you don't feel sleepy, as you did with the pasta, cereals, and bread, and so on, that has starchy food in it. And it's debatable right now. A lot of people say that you need to eliminate starchy food. Before, it was like we didn't have enough food in the world. That's why we were looking for starchy food. But right now, a lot of people have allergies, so starchy food may be just not a good choice for you. So glycogen, it's the storage form of glucose in animals. It's we have structure of the glycogen looks like this. Okay, they have many glucose molecules in here, and then in our body we store it in our liver and muscles. When you work out, when you run, when you do some physical activity, your glycogen storage drops down right away. When you eat like something sweet, so let's say some sugar candy or something like that, you can get your glycogen storage back. You will feel energized. That's why a lot of athletes, once they finish their workout, they eat something sweet to get their glycogen storage back. This is very similar to starch, the glycogen, and this is in our body. But the but the plants, they store their energy as a cellulose. It's a structural component in plants used to make cell walls. So you see, like we have the wood. If you cut the wood, you got the branch of the wood. If you would taste it, you would feel that the wood tastes a little sweet taste. It is because of the cellulose. Cellulose has inside glucose molecules, which taste sweet, right? But because it's super hard for us to digest, it's actually impossible for us to digest the cellulose, because we don't have the enzyme to break the wood. Okay, so as it says in terms of a joke, don't eat the wood, you can, because we won't be able to digest it. Now, the physical properties of monosaccharides, disaccharides, polysaccharides, you need to know this by heart. They are all crystalline except the polysaccharides. They are soluble in water, the mono and disaccharide, but polysaccharides is not so soluble. Monosaccharide is sweet to taste, disaccharide sweet to taste, but polysaccharide not sweet. The only part, it may be just a little bit. Okay, as I told you, like cellulose, like from the wood, you take it a bit, like you feel the sweetness in it a little bit, but just a little bit. Okay, and then monosaccharide needs digestion to be absorbed into the bloodstream. Okay, disaccharide, it's more or less the same, but polysaccharides is different, must be digested before being absorbed. Okay, and then polysaccharides form colloidal suspensions instead of solutions. So I would say Google about this stuff. It's going to be too long for me to explain it in the video, and we won't really ask you that kind of questions. And there was one more reaction that we covered. I'm going to finish up with that. This is again our carbohydrate. This is the photosynthesis reaction. You need to know this. And then the production of sucrose is sugar. Sucrose is another saccharide. And the way to get the sugar, we get extraction, purification, concentration, separation. This is how they make the sugar in the industry. And they also produce cellulose in the fabrics too. These are just the general information. If you want to check out if anything has a starch in it, starch is polysaccharide. You need to test it with iodine. If you add iodine inside on top of, let's say, a potato, you would see that it gets a dark blue-black color, and you would know that there was starch in it. Okay, starch in it. That's how the people test the starch. And we did check together in the lab with some of you, and we will do it with the other students on Wednesday. So we did it with glucose. In glucose, as you see, I've got on top aldehyde, right? And we're gonna add with you the silver oxide solution, which is oxidizing agent, meaning that it will oxidize that the chemical that will come in contact with. So as you see, we went from aldehyde into carboxylic acid. You see this oxide of silver went and then made this oxygen. Like oxide went in here and made the oxygen and left without the oxygen. That's why it gives silver, okay? And your reaction will give positive test if you would have a glucose in it, meaning that it might get oxidized if you have glucose. That's why your silver mirror test will result positive, and you will see this in the lab. And this is the reaction. It's written in Russian. I don't like the way they write it in the Russian textbook because it's kind of hard for us to see it. I would rather to write it in an open chain like this, okay, like shown in here. So open chain is better to see visualization. We see that the top part is aldehyde, and we change it to carboxylic acid. And this is what they do in here. So aldehyde, change it to carboxylic acid, and you have silver as a product, while this one is the silver oxide going in as a reactant. Now the rest of the stuff, don't worry about it. We don't have this. We're not going to cover this, and neither this slide. Don't worry about it. Don't worry about this one either. Just check out the stuff that I discussed in the video, and this is going to be enough for your exam. Thank you very much, and good luck.